Gas giants create something that makes close orbits impossible. Something that the movie completely ignores. Something that would kill everything on Pandora in hours. Gas giants generate lethal radiation belts that sterilize everything nearby. If Pandora were real and orbiting that close to a Jupiter-sized planet, the surface would be bathed in radiation levels that destroy DNA faster than any biological system could repair it. Yet in Avatar, humans walk around in t-shirts with light respirators. The Na'vi live their entire lives under open sky. They hunt, they build, they fall in love, all while bathed in lethal radiation they don't know exists. No pain, no warning signs, just slow death. The movie shows us a paradise, but beneath that beauty is a slow death that no one sees coming. Pandora looks like a lush world with floating mountains and bioluminescent forests. But it orbits a gas giant called Polyphemus, and that setup creates a fundamental problem the film completely ignores. We're going to look at what Jupiter teaches us about why Pandora's environment is scientifically impossible. Jupiter has a magnetosphere that's 20,000 times stronger than Earth's. That magnetic field traps high-energy particles from the solar wind and from volcanic activity on its moon Io. These charged particles get caught in the magnetic field lines and spiral back and forth between Jupiter's magnetic poles, creating zones of intense radiation that surround the planet like invisible death belts. The mechanism works like this. Charged particles, mostly electrons and protons, move along magnetic field lines at nearly the speed of light. When they encounter Jupiter's magnetic field, they can't escape. They bounce between the north and south magnetic poles, accelerating with each pass. Over time, these particles accumulate into dense radiation belts that extend hundreds of thousands of kilometers from the planet's surface. The radiation levels are staggering. Europa, one of Jupiter's moons, receives about 5,400 millisieverts of radiation per day. To put that in perspective, 5,000 millisieverts is considered a lethal dose for humans. Europa gets more than that every single day. A human standing on Europa's surface would receive a fatal dose in less than 24 hours, even inside a spacesuit. But here's what that actually means. The radiation would penetrate deep into cells, shattering DNA strands and triggering uncontrolled cell death. Astronauts exposed to even a fraction of that dose develop radiation sickness within hours, nausea, vomiting, organ failure. The high-energy particles don't just damage surface tissue. They punch through skin, muscle, and bone, destroying the molecular machinery that keeps cells alive. Europa gets more than a lethal dose every single day. But here's the thing. Europa is smaller and farther from Jupiter than Pandora is from Polyphemus, which means Pandora's radiation environment is even worse. We're not talking about a hostile moon that might kill you. We're talking about a world where the radiation is so intense that nothing should survive at all. Now let's talk about Polyphemus, the gas giant Pandora orbits in Avatar. The movie implies it's even larger than Jupiter. Bigger planet means stronger magnetic field. Stronger magnetic field means more intense radiation belts. The physics scales up, not down. Now here's where Avatar's visual design becomes a physics problem. The movie shows Polyphemus dominating the sky for a reason, and that reason is also the reason nothing should be alive down there. Pandora orbits close enough to Polyphemus to be tidally locked. That means one side of Pandora always faces the gas giant, just like one side of our moon always faces Earth. Tidal locking only happens when a moon orbits relatively close to its parent planet. That places Pandora deep inside the danger zone, where radiation belt intensity peaks. In the film, we see Polyphemus dominating Pandora's sky, massive, looming, impossible to ignore. That's what tidal locking looks like visually. The gas giant fills the horizon, a constant presence overhead. But that close proximity is exactly what traps Pandora inside the radiation belt's danger zone. The movie uses the gas giant as a visual spectacle, not realizing it's also a radiation gun pointed directly at the surface. The movie never addresses this. Humans walk around in t-shirts with simple air masks. The Na'vi live their entire lives exposed to open sky. The forests are full of complex life forms, from tiny insects to massive creatures. All of that requires stable DNA and functioning cellular repair mechanisms. But constant bombardment from a gas giant's radiation belt would destroy that faster than any biological system could repair it. The distance problem is unavoidable. Pandora would need to orbit much farther from Polyphemus to escape the worst of the radiation belts. But then it wouldn't be tidally locked. Or Pandora would need its own impossibly strong magnetic field to deflect the radiation. But moons don't generate magnetic fields anywhere near that powerful. The physics doesn't allow for both a close orbit and a habitable surface. The movie's solution is laughably inadequate. Humans on Pandora wear simple respirators and light clothing. Some scenes show them in standard military gear. That might protect you from Pandora's atmosphere, but it does absolutely nothing against high-energy radiation. Let's break down the math. A lead vest that protects against X-rays in a hospital is about half a centimeter thick and weighs several kilograms. To stop the kind of radiation Europa experiences, you'd need lead shielding at least 10 centimeters thick, covering your entire body. That's not a light fabric mask and cargo pants. That's a walking tank. If this breakdown is blowing your mind, drop a like. And if you know someone who thinks Avatar's science is flawless, send them this video. Compare that to real astronauts. An ISS spacesuit weighs 280 pounds and includes multiple layers of radiation shielding, water cooling systems, and micrometeorite protection. And astronauts on the ISS, orbiting in Earth's protective magnetic field, still limit their time in space to manage radiation exposure. Now, imagine needing that level of protection just to step outside on Pandora. The Na'vi would need to be encased in armor, not running through forests in loincloths. They couldn't hunt. They couldn't feel the wind. They couldn't live as the movie shows them living. But let's say we suspend disbelief. Let's say the Na'vi somehow evolved radiation resistance. That still doesn't save Pandora. Because there's one thing you can't evolve your way around, and it affects every living thing on that moon. Take the bioluminescent forests we see in Avatar. Those plants depend on photosynthesis, a process that requires stable DNA and precise enzyme function. Constant radiation damage would cripple that process. The plants would sicken and die. Without plants, the herbivores starve. Without herbivores, the predators, including the Na'vi, have no food. The entire ecosystem collapses from the bottom up. Physics doesn't care about narrative convenience. Either Pandora orbits much farther from Polyphemus, well beyond the radiation belt danger zone, or everything on that moon is dead. There's no middle ground where you get spectacular close-up views of a gas giant and a thriving biosphere at the same time. The realistic alternatives are simple. Push Pandora's orbit out to a safer distance, but then you lose the tidal locking and the visual drama of Polyphemus dominating the sky. Or give Pandora an impossibly powerful magnetic field of its own. But moons don't generate fields strong enough to deflect gas giant radiation. Some sci-fi gets this right. In The Expanse, they acknowledge the danger. Moons near gas giants require heavy shielding or safer orbital positions. In Interstellar, the filmmakers acknowledge the extreme physics of orbiting a black hole. Avatar doesn't even try to explain the contradiction. It just ignores the physics entirely. Avatar is a masterpiece of world-building and visual storytelling, but it chose spectacle over science, and the cost of that choice is a world that shouldn't exist. The physics just doesn't allow what the movie wants to show. The Na'vi live their entire lives under open sky. They hunt, they build, they fall in love, all while bathed in lethal radiation they don't know exists. No pain, no warning signs, just slow death. That's the tragedy of Pandora. Not that it's scientifically impossible, but that if it were real, the Na'vi would never see it coming. They'd live their whole lives thinking they were free, never knowing that the very world they love is slowly killing them. This is what happens when filmmakers prioritize spectacle over science. They create worlds that look beautiful, but are fundamentally broken. And the people living in those worlds never get to know the truth. Next video, we're looking at what happens when a black hole gets close enough to a habitable planet. Spoiler: Interstellar got it mostly right, but there's one detail that would still destroy everything. You won't want to miss it. If you want more breakdowns that expose the physics hiding in plain sight, subscribe. And tell me in the comments, what's the next space myth you want me to destroy?